All right, we're going to take a look at solving polynomials by factoring here. And this is lesson 4-0 for pre-calculus. So some of the things we're going to look at are steps for factoring polynomials. That includes number one, always look for a common term. This is one of the most commonly missed things when we look for factoring polynomials. If I look at all four of these terms, I notice immediately that they're all divisible by 4 and they all contain at least an x to the first power. So I can actually factor out. So let me get my pen color right here. We'll start off with red here. We'll factor out a 4x. And so if I factor a 4x out of the first term, that leaves me x cubed. The second term I factor out a 4x, it leaves me 2x squared. The third term I factor out a 4x, and that leaves me negative 3x. And the last term, if you factor out a 4x, you can't put nothing there, because think of it as 4x divided by 4x, which would be plus 1. Now, the other way to look at this is if I were to redistribute the 4x back in and there was nothing at the end here, I would end up with nothing at the end here. Okay, so if you factor out the whole term, there's got to be a placeholder of 1. The second thing we look for is called a difference of two squares. These are what these are. These are both perfect square terms. You'll notice 9x to the fourth is a perfect square because it's 3x squared times 3x squared. We all know that 25 is a perfect square term. And so these have a nice little pattern that we can factor them in. 3x squared plus 25 times 3x squared minus 25. All right? And sometimes you can actually factor the second term again, but oops, you know what? I wrote 25 instead of 5 on those. That's my mistake here. So 3x squared plus 5 and 3x squared minus 5. And sometimes, again, you can factor out the second one again. If that was 4x squared and minus 25, we could actually do that one again. Okay, so you just want to watch for that. Sum and difference of cubes. A difference of cubes is something like x cubed minus 27. And it always factors out with the same pattern. If you look at what is the cube root of x cubed, that's x. What is the cube root of 27? Well, that's 3. All right, so if you notice my first factor here, it has an x minus 3, so it has the same sign. And then my second factor is the first term squared, so x times x gives me x squared. Notice my second term, x times 3 gives me 3x. So the first part of this times the second part gives me this. Now notice the sign though did change from negative to positive. It's always going to be like that. And then my last term is just 3 times 3. Okay? If you look at the pattern to the right, if I recognize something as a cubed minus b cubed, the first factor is always going to be a minus b. And then the next factor is always going to be the first term squared is up front, the last term squared is in the back, and the two terms multiplied by each other are in the middle with the opposite sign right here after the a squared. The last term is always positive. Okay? Sometimes we have a little acronym, refer to this as SOAP. Okay? So SOAP means same sign as the first term, opposite sign as the very first part, and then always positive for the last term. All right? Number 4, trinomials into binomials. So a trinomial is something that you're familiar with, and this is going to be something simple like, for instance, I don't know, x squared minus 3x minus 4. Okay, so that's a trinomial. That's a second degree trinomial, but we're going to look at 4th degree, 6 degrees, that kind of thing. And then the last one is 4-term 3rd degree polynomial, and we're going to do those by grouping. So that might be something like, and I don't even know if this one's factorable, x cubed plus 2x squared plus 2x plus 1. Okay? So it could be something like that, and we're going to talk about how to factor those as well. All right? So our first example here, it says, number 1, factor completely. So technically, if it's just saying factor, I don't even have to worry about the equal sign here. So I'm not sure why that's on there, but the first thing I always want to do is go to the top of the steps. This one says to everything. look for a common term first. Always look for a common term. I can factor out a 9x from there. So I'm going to do that. I'm going to factor out 9x. That's going to leave me with x squared minus 4 left over. Now, again, because I'm not solving, I'm not really worried about the equal 0. The 9x is done, but the x squared minus 4, that's number 2 on your list. This is a difference of two squares. Sometimes you can continue to factor, other times you can't. So this would be x plus 2 times x minus 2. All right, so common terms, difference of squares. All right, number 2, factor x to the 4th minus 2x squared minus 15. If it looks like a quadratic trinomial, then try to factor it using the same methods. What do I mean by that? I'm going to do something that we do a lot in calculus. We're going to do what's called a u substitution here. So I'm going to substitute u in place of x squared in this problem right here. Okay? So I'm going to take this guy right here, and because x squared times x squared is x to the 4th, then u times u would be u squared for the first term. So u squared represents the x to the 4th minus 2x squared. So this is just going to be minus 2u, because again, u's going in for x squared minus 15. Now this should be a fairly simple problem to factor here. If you, regardless of your methods for doing it, this would be u minus, what do we got here? U minus 5 times u minus 3. So I have that factored. And now what I want to do is I want to take this guy and I want to replace u with x squared. So I want to put the x squared back where it came from. So I would end up with, now I'm going to come back over here. So this would end up being x squared minus 5 times x squared minus 3. Neither one of those are a difference of 2 squares, so I don't have to worry about factoring either one of those. But you can kind of see the connection between a 4th degree and a 2nd degree and how they factor out the same way. The same thing happens on example number 3. You can do a u substitution here as well. So I'm going to come over here and I'm going to let u equal x squared. And so this is going to be 2u squared minus 11u plus 12. And I'm going to factor this. In order to get a 2u squared, I know I need 2u and a u. Now, to get a positive 12 at the end, there's a lot of possibilities there. It could be 1 and 12, it could be 2 and 6, it could be a number of different things, but because my middle term's negative, I know that whatever pair of numbers I pick to go in these parentheses, they've both got to be negative, because they're going to add to a negative in the middle, and they're going to multiply to a positive at the end. So if I choose negative 3 and negative 4, okay, if you check your FOIL, you get 2u squared minus minus 8u minus another 3u, so that's going to give me negative 11u, and then negative 3 times negative 4 is positive 12. But I don't get to stop there. I need to come back over here. I need to replace my u with x squared, so this is going to be 2x squared minus 3 and x squared minus 4. Now obviously if you don't have to do the u substitution part, that's great, okay? But once I get done here, I need to look at both of these sets. Are either one of these a difference of 2 squares? Okay, the first one's definitely not. There's nothing you can do with 2x squared minus 3. But the second one is definitely what we call a difference of 2 perfect squares. So this is x plus 2 times x minus 2. All right? Okay. What did that one? Did that one actually say solve, or did it say to just factor? Looks like it just says factor on this one, so we'll just keep going with factoring here. All right, next page. All right. Oh, it does say solve polynomials by factoring, so I wonder if, well, we'll solve the other two here. How's that? All right, so here we go. Factoring by grouping. Okay, so the steps for grouping, factoring by grouping works really well when you have an even number of terms. The most common one that we're going to run into is 4-term polynomials that are to the 3rd power. Okay, now this will work with other kinds of polynomials, but this is the most common one that we're going to run into. So the steps on the side say group the first 2 terms and the second 2 terms in parentheses. So I'm going to start off by grouping 4x cubed minus 3x squared together, and then I'm going to group the negative 8x plus 6, and it does say to solve, so we are going to make sure that equals 0 stays on there, and I'm going to drop a plus sign in between. You'll notice I left the negative with the 8x. All right, if you put the negative on the outside, then you've got to change this positive 6 to a negative as well. All right, so hopefully you kind of see how the distribution of the negative would work there, but if you want to put the negative on the outside, that's fine. You just got to change both signs inside the second set. The next thing we want to do is factor the greatest common factor from each set of parentheses. So I'm going to look at this first set of parentheses and ask myself, what can I factor out of here? I can factor out an x squared. That leaves me 4x minus 3. Now that doesn't mean I have to factor an x squared out of the second one. I can factor out anything I want. I want to factor out the GCF. So most people would say, let's factor out 2. But because my 8 is negative, I'm going to factor out a negative 2. So that's going to leave me positive 4x minus 3. Now what should be happening here is these 2 sets of parentheses should be exactly the same. If these guys are not the same, you've got one of 2 things going on. This thing's either not going to factor the way you want it to, or you've done something wrong. Okay? Now, when we go to factor the common factor from each grouping, well, let me make a little note here, okay? So let me put a little note here. These guys must match, right? The next step is the more confusing one for a lot of people. So it says factor the common factor from each grouping. Now, here's what you got to understand. Again, I'm going to do a U substitution here, all right? So I'm going to, let me change colors here. I'm going to let U equal 4x minus 3. Okay, so I'm doing a U substitution just like I did on the front page, but this time U is going to equal to 4x minus 3. So watch this. I'm going to take out the 4x minus 3 and I'm going to put in U. So I have x squared times U minus 2 times U. Now if I said factor the common factor from each one of those, it should be obvious that U is the common factor. So I would factor out a U, and I would have x squared minus 2 left over. All right? Now, at this point, we want to replace U with 4x minus 3. So, watch and see. Replacing U with 4x minus 3 leaves me 4x minus 3 times x squared minus 2. Now, hopefully you can kind of see the connection between above in the green and down here. Because when it says to factor out the common factor, my common factor is what I highlighted in yellow. What I actually did from the green and yellow down to the red was I factored out a 4x minus 3 from both of the terms up above, and I was left with the x squared minus 2 as my second factor. Remember, these are both still equal to 0 because we are solving. Now we just want to set each of the factors equal to 0. 4x minus 3 equal to 0. X squared minus 2 equal to 0. We add 3 to both sides here. We get, let's do plus 3 plus 3. We get 4x equals 3. And we'll go ahead and divide out the 4, so x is equal to 3/4. There's one solution. We'll go ahead and add 2 here. That leaves x squared equal to 2. Then we're going to go ahead and square root both sides. The square root of x squared equals the square root of 2. we need a plus and a minus right here. And so we have x equals plus and minus the square root of 2 as our result. So we have 3 answers here, okay? These are 3 real solutions. 3 real solutions. All right? And also, I'm going to mention something else. This was a third-degree polynomial. Third-degree polynomials have 3 solutions. In this case, they were all real. Okay? So let's try another one. I would encourage you to turn off the video at this point and try this on your own. See what you can come up with. All right? So here we go. Number 1, following the steps from above, is to group the terms. So I'm going to group 4x cubed. I'm going to group negative 6x squared together. I'm going to group 10x minus 15 together. I'm going to drop a plus sign in the middle. And I'm going to keep it equal to 0 because we are going to solve it. Step number 2 says factor the GCF out of each set. So I go to the first set, I can factor out a 2x squared here. So 2x squared times 2x minus 3. I go to the second set, I can factor out a 5. So I get 5 times 2x minus 3. Notice what's in my parentheses matches. It's exactly the same. So again, just to show you what's happening here, I'm going to do a little u substitution. I'm going to let u equal 2x minus 3. So I have 2x squared times u plus 5 times u. My next step says factor the common factor out of this. The common factor here is u, but really what we're saying is the common factor is 2x minus 3. So u times 2x squared plus 5. If I replace the u with 2x minus 3, look at what I get. 2x minus 3 times 2x squared plus 5 equal to 0. All right? So that should be a squared up there. I messed up on that there. Let's try this again. 2x squared. All right. Set them both equal to 0. 2x minus 3 equal to 0. 2x squared plus 5 equal to 0. I'm going to go ahead and add 3 plus 3. We get 2x equals 3. So x equals 3 halves. On the next one, we're going to subtract 5. Subtract 5. We get 2x squared equals negative 5. We're going to divide out the 2. That's going to leave x squared equals negative 5 over 2. We're going to square root both sides, just like we did before. So we get the square root of negative 5 halves. So x is equal to, and yes, even though there's a negative inside, I still need a plus and a minus out here. So I have plus and minus the square root of negative 5 over the square root of 2. Now, there's a couple of different things we can do from here, and since we're at the end of the lesson, I'm just going to go ahead and take a look at them real quick. I think we're at the end of the lesson here, aren't we? Let me double check here. Uh-oh. There must be homework down there. Oh, yeah. All right, so take a look at what we actually have here. There's a couple of things that sometimes you need to be able to do. Number 1 is to recognize that the root has a negative inside, which means we have one real solution here, one real solution, and we have 2 imaginary solutions here. Okay, so we still have a total of 3 solutions from a third-degree polynomial. However, if we wanted to keep going on the imaginary solutions, there's 2 things that we could do here. Number 1, we can rewrite this with a negative outside and call it an I value. So x equals plus and minus I times the square root of 5, all divided by the square root of 2. Okay? You guys remember the I value, the negative inside the root becomes an I value, saying it's imaginary. The other thing we can do is we can take this solution and do what's called rationalizing. We can rationalize the denominator, which means multiply the top and the bottom by this root in the denominator. So I'm going to do that in my next step. X equals plus or minus I. And I don't care what's in the numerator, I just care what's in the denominator. So I'm going to take my root 5 in the numerator here, square root 5 over square root 2, and I'm going to multiply this by root 2 over root 2. Now let's just do the math and then we'll talk about it. So I'm going to end up with x equals plus and minus I, root 5 times root 2 is root 10, and root 2 times root 2 is root 4, but root 4 is just 2. These two guys mean the exact same thing. All right? And there you go. That's it for lesson 4-0.